Hello students. So today in this class we'll learn about logarithms, and this is a part 1 of logarithms. We'll have a coming video on logarithm in the next class, but today's objective is we will have a short introduction of what is logarithm and where we can use them. We will also have some basic laws on logarithm and also properties, and we'll compare the natural logarithm versus the common logarithm. So before proceeding further, I want to revise the basic concepts on index laws, which will be helpful. So this is the first law. So a to the power m times a to the power n is equal to a to the power m plus n. So here a is called the base, right? And m is called the powers or the exponents. And so here, if the bases are same and the multiplication sign is there, then the powers are added. So this is just an example here. 2 to the power 5 times 2 to the power 3 will be equal to 2 to the power 8. Similarly, if the bases are same and the division sign is there, then the powers are subtracted. Here this is an example of 5 to the power 7 divided by 5 to the power 3. We can get 5 to the power 7 minus 3, that is equal to 5 to the power 4, right? So similarly, the third law is of indices is a to the power m within bracket to the power n. Then bracket means the powers are multiplied here. If the So we can get of a to the power m times n. This is an example, 10 to the power 3, and within brackets and outside the bracket their power is 7. Then you get 7 times 3 as a power, new power or new exponent, and you get 10 to the power 21. This is another example. So a to the power 1 is equal to a, where a is any real number. So here, whatever be the real number and the power is 1 or the exponent is 1, the value we get is the same. Uh, Similarly, if the power or the exponent is 0 and you get a value of 1 irrespective of whatever number you have as an a. For example, even if you have 1 million, to the power 0 is 1. Okay, so the exponent plays a very important role. So another example of the law is a by b is in the form of rational number. To the power m is equal to a to the power m divided by b to the power m. So individually the powers or the exponents get affected with both numerator and denominator. Here 5 by 6 is just an example. To the power 2 is equal to 25, or 5 square divided by 6 square, which is 36. Similarly, if the power or the exponent is a negative number, that is minus m, for example in this case, then the answer becomes a reciprocal of that number. For example, a to the power minus m becomes 1 by a to the power m. Example is here, 9 to the power minus 2, right, is equal to 1 divided by 9 to the power 2, which is 9 square, which we can write as 1 by 81. Another example of the indices laws is a to the power x by y. Okay, here x is numerator and y is denominator. We can write it as yth root of a to the power x. Okay, for example, 49 to the power half. So the power is 1 by 2. We can write it as square root of 49, which is equal to 7, because 49 is 7 to the power 2, right? And the power becomes 7 to the power 2 by 2, that means 1. Okay, also you should know, before proceeding further, this is the exponential form, and this is one form is called the radical form. For example, x to the power half, this is the exponential, right, to a power or the exponent. And so this is the exponential form, and if whenever the same thing we can write it as root over x, then root over x is the radical form. Similarly, x to the power 1 by 3 is the exponential form, and cube root of x is the radical form. So these two are interchangeable. Okay, we will see here, for example, square root of 5 cube is this is the radical form, right? And you can transform this radical form to the exponential form as 5 to the power 3 divided by 2, as the power is 1 by 2 here. Square root means the power is 1 by 2, and already the 3 was there. So it becomes 3 times 1 by 2. That means 3 by 2. So what is logarithm? The meaning of the word log with base a of b. So what does it mean? So before that, you should know what is an exponential equation. So what is an exponential equation? For example, you can see that a to the power x is equal to b. This is an exponential equation. Exponent is nothing but the x. X is the power, okay? In this form of equation, we call it as exponential equation or exponential form of the equation. So here a is the base, okay, x is the exponent, and b is the final value of whatever you get, a to the power x, right? So for example, 2 to the power 5 means what? Means it is 2 times 2 times 2 times 2 times 2. That means it equals to 32, right? So here you get the value of 32 of 2 to the power 5. So here base is 2, okay, exponent is 5, and the value you get is 32, okay? So exponent of 2 is 5, okay? So here, to logarithmic form, we can rewrite the same form of exponential equation to log with base 2. So base is same, base you can see is same, log with base 2 of 32. So whatever you have got in the right hand side, so log of with base 2 of 32 is equal to 5. So 5 is the exponent or the power. So here the power or the exponent, whichever was there in the exponential form, is the answer in the logarithmic form. So here we can see with another example to make it more clearer. So for example, 3 to the power 4 is equal to 3 times 3 times 3 times 3, which is equal to 81. So here what is the power? It is the 4. What is the base? It is a 3. And what is the value of 3 to the power 4? We get 81. So what you can write as exponent? Which is the exponent? Exponent is 4. And the base is 3. So we can write in logarithmic form as log of 81, okay, with base 3, so the base is 3, is 4. So exponent of 3 is 4, that means 4 should be the answer. Exponent of 2 is 5, that means 5 should be the answer in logarithmic form. Okay, and the base will be the same. So whatever is the indices in the exponential form, whatever was the base a, here it is also named as base in logarithmic form. So we write it as 2. And whatever was the value in the exponential form, we can write it here. We call it as argument. I will tell you shortly. So it's true for any two numbers like a, b, and c. For example, a and b are two numbers. There exists a third number c, so that we can write a to the power c is equal to b. Okay, so if a to the power c is equal to b, with what form of equation is it? It is the exponential form. And what form of the same equation we can rewrite in logarithmic form as log with base a of b. So b we can write is the answer as c. So the same exponential form in logarithmic form we can write the equation. Okay, and this a is called the same base. So it is a is the base for both exponential and logarithmic form. B is called the argument. So b is the value in our exponential form. We call it as argument in the logarithmic form. And c is the exponent, right? In exponential form, c was the exponent. So here you get the c exponent of a, right? And how we read it? We read it as c is the logarithm to base a of b. So logarithm of base a of b is c. Okay, so we have to remember that we can calculate the logarithm with the help of a calculator. And before we used to use a log table, but nowadays you will get your calculator to find out the value of logarithm. And most importantly, you need to remember that your logarithmic calculator mostly gives the value of log with base 10. So you need not enter the number 10, but it is automatically by default whenever you enter the term log of 5, that means it is giving the value of log of 5 with base 10, not any other basis. Okay, so we will see later on how we can, if we want to find out the logarithmic value of other base, how can we do that. But for your calculator, you need to remember that mostly your calculator will give the value of log with base 10. So it is also called as common logs. It's very common. The base 10 is very common. And for example, log of x, for example, if we don't write the base, that means it's implied that the base is 10. We are talking about the common log. Okay. Okay, so for example, if you want to find out the logarithm of other bases, how can we do that with a calculator which gives the value of only with a base 10? So here we can use our change of base formula, which is log of b with base a, right, is equal to log of b with base c. So we are changing the base, divided by log of a with base c. On right hand side, you can notice that both numerator and denominator have a common base, have the same base as c. Okay, and here whatever on left hand side was the argument, it comes to numerator, and whatever was the base, it comes to denominator. Okay, so please remember this formula by heart. We can practice the given with the formula. How can we find out the value of this example? Exponent. So it's given that 2 to the power x is equal to 50, right? And with the help of logarithm, we can find out unknown powers or unknown exponents. That's the whole purpose of logarithm. So first step is we will convert it to logarithmic form. So this form was exponential form. So we are changing it to logarithmic form. So we can write it as log of 50, right, with base 2 is equal to x. The base change formula, whatever is there on their top, to convert this form to an reusable form so that we can find out with the help of calculator, because you can see here the base is 2 and our calculator may not give a value of this one with base 2. So what we can do, we can use the base change formula, like log of 50 with base 2 will be equal to log of 50 with base 10. So 50 was the argument on the left hand side, so it comes to numerator, divided by log of 2 with base 10. So here you have to remember that both are of same basis, so bases are 10 because we can easily calculate, and here whatever was the argument on the left hand side comes to the numerator, and whatever was the base on the left hand side, it comes to the denominator. And now finally you can calculate it to be 5.64. So you can calculate log of 50, you can calculate log of 2 and just divide it, and you get the value of 5.64. We can do a similar example. For example, log of 7 root over 7 with base 7, okay, is equal to x. So x is it's in logarithmic equation, right? And we have to find out the value of x. Okay. So we are rearranging the above question here. So if you can see 7 root over, right? What does root over mean? Square root. That means the exponent is 1 by 2. We know from the indices laws. So it is the exponent becomes 1 by 2. Okay, so we are just changing it to the proper exponential form, and then we can write down as log of 7 to the power 3 by 2. Why 3 by 2? Because if you see here, there are two terms with the same basis, common basis, 7, right? And here nothing is there. That means it is 7 to the power 1. So 1 and half, that means the powers are added, right? And so here 1 plus 1 by 2, which becomes 3 by 2. Okay? So it becomes log of 7 to the power 3 by 2 with base 7 will be equal to x. Okay, so now we can rewrite as an exponential form, right? If you can see this is the logarithmic form. Now how can we change it to exponential form? So this is the exponent, so we can write 7 to the power x. So 7 is the base, x is the exponent, so we are changing to exponential form. So 7 to the power x is equal to argument. So argument was 7 to the power 3 by 2. So here if you can see 7 to the power x becomes equal to 7 to the power 3 by 2. We are just rearranging it to exponential form. So this is the logarithmic form, this is the exponential form. And from this equation, it is easily understandable that if the bases are same, the powers are also same, provided the equality sign is there. So 7 to the power x is 7 to the power 3 by 2. If this condition is correct, then we can write x is equal to 3 by 2 from the indices laws. Okay, so this type of questions will more solve today during the class time. And before that, I want you to understand some more important facts. So for example, if log of n with base a, so if this is a form of given in your question and n, that is the argument, is greater than 0. So n is greater than 0, that means the whole value will be real. Okay, so for example, log of 5 with base 2 will be real because 5 is the argument which is greater than 0. Now for example, if the argument is less than 0, then the whole thing will be imaginary. Okay, and if the argument is equal to 0, that means the whole form will be not defined. Okay, we will do questions mainly related to the first category, that is a real logarithm. But you need to understand that we can do that for the higher classes. Okay, for the imaginary and the non-defined. Some more important facts. So the logarithm of 1 to any base a. So whatever be the base a, if the argument is 1, then the value will be 0. Okay. For example, log of 1 with base 2 is equal to 0, right? Log of 1 with base 3 equal to 0. So irrespective of whatever is the base, if the argument is 1, that means the value of logarithm you get as 0. Okay, this is an important fact. Second important thing is the logarithm of any number where a is greater than 0, okay, and the base with the same base. That means if the base as well as the argument is the same number, that means the value of the whole logarithm becomes 1. For example, log of 2 with base 2 is 1. Log of 50 with base 50 is 1. Okay, this is the second important fact. By seeing the question, you should understand that okay, this is the argument is 1, that means the value should be 0. Okay, both bases and argument are equal, the value should be 1. Okay, so these are the important facts that you need to know while doing the difficult problems. So the third fact is here is if a and x are positive. So for example, this is given a and x is positive real number, like we can write the exponent as a to the power log with base a of x. We get the value of x. So here if the power for example has a base a and the logarithm also have a base a, so the logarithm is in the power. Okay, so we get the value of the argument whatever is in the power of the logarithm. Okay, for example, 2 to the power log of 5 with base 2 is 5. 8 to the power log of 9 base 8 is 9. So if the log base and the exponent whatever base is the same, that means you get this value. Okay, now you will do this worksheet, so I will advise you just pause the video and do this worksheet. I will share the answers of this worksheet in the next video so that you can tally it. and these are some of the questions that you need to complete before proceeding further. Okay. Next, we will learn about the laws of logarithm. Okay, so basically there are three types of laws in logarithm. We call one as product law, which is we can write it of the form of log of mm times n with base b, okay, will be equal to log of m with base b plus log of n with base b. Okay, so here this is the product law. This is similar to indices. So log of mn, if the argument we can express is as a product of two numbers like m times n, then we will simply add up the logarithm with the common basis. So if you can see, the basis has to be the same across, so right hand side across the left hand side. Okay, so this is the product law. We will see through with the example. And the power law, this is the second category of laws of logarithm, which we can write it as log of m to the power k. So if the argument can be expressed as a power, like m to the power k, so with the base b, okay, we can write down as k times log of m with base b. So the power of the argument becomes as a whole number outside the logarithm. So this is a form of expression we can write it down for in the power law. Okay. So the third law is the quotient law. Okay, the quotient law says us that log of m by n. So the argument can be written as a rational number or a p by q format or m by n with base b. Okay, so the base is b. We can write down as log of m of with base b minus of log of n with base b. It will be similar to the law of indices as we have done before. Most importantly, we have to remember that b, whatever is the base, should be greater than 0 but not equal to 1. So just remember that for those, the value of b should be greater than 0 and not equal to 1. All these laws are valid. And of course, the m, n, and k are real numbers. As I told before, that we'll be dealing with the real logarithms, and m and n must be positive. Okay. So more examples here of the product law is you can see that here the argument taken as 15 and the base taken as 2. So 15 we can write it down as a product of 5 times 3. So here we can say that log of 5 with base 2 plus log of 3 with base 2. So this is just an example of logarithmic product form or product law can be applied. Okay. The second one is the power law, right? So here if you can see, the logarithmic value of the argument can be written as 2 to the power 5 and nothing is there, that means it is the base 10, right? So here we can write it as it is a product form, that is we can write it as log of n to the power k. So k as the power has come outside the log, so 5 has come as a 5 log 2. It is a similar form. So it is the power law. Now the third law is the quotient law, right? Here the argument can be written as 3 by 7. So here with the base has 2, so we can write it down as the numerator, whatever was the argument was there, so log of 3 with base 2 minus log of 7 with base 2 in this case. So this is just an example of the quotient law. Okay. Some more laws that needs to be known are this one, that is log of x with base a will be equal to 1 divided by log of a with base x. So it is just interchanged. The base and arguments are interchanged. So we'll see more applications of the laws in the problems that we want to do for the entrance examinations. So here, this is one important law. An example of this law is, for example, log of 2 with base 5. We can write it down as 1 by log of 5 with base 2. This is the second important law that we need to understand, that log of x with power with base as a to the power n. So the base is in the format of a to the power n. We can write down as 1 by n, okay, 1 by n of log of x. So if we want to change the power from a to the power n to a, for example, then we need to transfer the power of n, whatever was there in the base, in this format. So 1 by n log of x with base a. So this is also useful for many numericals that we'll encounter. For example, log of 7 with base 8. So 8 can be written as 2 to the power 3, right? So here we want to change from 8 base 8 to base 2. So simply we'll use this law. So here we need not calculate, okay, we need to understand what is, so we will just use the law, and here we can write as 2 to the power 3, right? So 2 to the power 3, that means the 3 is the power, so it will come as 1 by 3 outside the logarithm. So 1 by 3 of log of 7 with base 2. So this is just an application. The third law is log of x to the power m, and the base is a to the power n. So if you see here, both arguments and the base are in exponential form. One argument has a power or exponent as m, and the base have an exponent of n. Okay, so we can write down as m by n of log of x with base a. This is also useful to understand that if we want to change the bases, we need to understand the application of what and where to apply this law. This is just an example of this particular law of a log of 2 to the or log of 5 to the power 4 with base of 2 to the power 5. That means you can see that the argument has an exponent of 4 and the base has an argument the base has a power of 5. Then the whole number here comes out to be 4 upon 5. Okay, and here the base of left hand side and the right hand side is different. So here the base was to the power 5, and on right hand side the base is 2. Okay, and argument is also different. So argument of left hand side was 5 to the power 4, and here the argument is 5. Okay, now finally we'll just see the major difference between the natural logarithm versus the common logarithm. Common logarithm, we also encountered this word before in this video. So it's about the base 10. So it is a normal, most common form of logarithm that we'll be using. Another name is the Briggs logarithm, and here this is mostly used by the value that you get, the calculator gives, is the common logarithm. Okay. Now, what is natural logarithm? Natural logarithm has also a name of Napierian logarithm, and here the base is e. Okay, and here the e has a specific value of 2.71828 and so on. So it is approximately this value, and if the base is e, log of base e, we can also write it as ln format. So just for the information, so for example, instead of log something, if it is written ln, that means we have to understand that it is log of e, log with base e. Okay, so log of x with base e can be written as ln of x. For example, here log of 7 with base e can be written as ln of 7. Log of 1 by 64 with base e can be written as ln of 1 by 64. Okay, now we will also be doing some problems in the class time, and thank you